Hello and welcome everyone. We're going to be going through some of the terms that we've been learning to do throughout this geometry topic. So we're going to start with, I guess, the most crucial one, which is polygon. And we're going to answer some questions and provide some examples and non-examples for each one of these terms to help try and consolidate the different terms that we've been using in this topic, which will help us, obviously, when it comes to doing your topic tests, which will be going up on Canvas. All right, so let's look at the first term. I'll show you an example with this first one where I'll go through the different parts. And then for the following terms, what I'll get you to do is pause the video when we get to it, and you have a go at answering these parts yourself. Once you've had a go at that, you can unpause the video and I'll go through and I'll run through it, at least in my words, maybe slightly different to yours, but hopefully it will give us a good idea of where we're at and what each of the words mean. All right, so let's begin with the first one. So our first word, and probably the most crucial one in this geometry topic, is polygon, because every single question happened to be a polygon that we were working with. So firstly, what is it? This is where you just write down in your own words what that word means. So for me, I would say it is a two-dimensional shape with straight edges and no gaps. That's what it is. Looking at this, I see like three crucial elements to it, or outside of the fact that it happens to be a shape, and that is it's two-dimensional. So three-dimensional shapes are not considered polygons. All the edges are straight, and there are no gaps. They're the three crucial elements that make something a polygon. And if you think back over these lessons that we've been covering, every single question, right, it'll be a shape that fits one of those. Well, it'll have all three of those elements to it. All right, the next part, what do we do about, or what do we know about polygons? Okay, so again, what do we know? And again, you just write this in your own words. Well, in this particular case, we know that the shapes, they have, an equal number of sides and angles. So, if a polygon has three sides, it'll also have three angles. If it had five sides, it would have five angles. And, well, to be honest, we've had entire videos and lessons dedicated to polygons. There's lots of things you could write here. I might put in also that the angle sum of a polygon can be given by n minus 2 times 180, right? Just as an example. All right, on to the next section is where we provide some examples of what a polygon is. So in this section, we say, okay, well, the word is polygon, so let's do some examples of what a polygon would look like. So here we go. I'll put in a couple. There we go. There's one. And there's another one. The final section is where we put the non-examples. So these are ones that are like similar to it, but sort of fail that original criteria of what makes it a polygon. So we saw some of these non-examples in our very first lesson. A few examples would be, so let's put it here. Let's say we have something like this. Everything's looking really good, but then, oh, we've got a curved edge. That would be a non-example. Another classic one would be, you start doing your polygon looking thing, but you don't complete it off, you leave a gap there. I guess the third other classic non-example that we saw in our first lesson on this topic would be like a three-dimensional shape. That would also be a non-example. All right, now we're going to move on and look at some terms where I want you guys to do it yourselves. Okay, so pause the video. I want you guys to go through and fill out the 4 sections for a regular polygon. What is it? What do we know about it? Some examples and some non-examples. Once you've finished, unpause the video and I'll put up what an example of what I might do for this. Okay, so hopefully you've had a chance to go ahead and complete this. So what is it? Right, it is a polygon with equal side lengths and angles. What do we know about it? Well, other than the fact that in the definition that gives us quite a bit, right? All sides are equal in length. All angles are equal. Also, interestingly, and we learnt this, I think it was in the second last lesson of this topic, all exterior angles are equal and can be given by the result 360 divided by the number of sides n. So just a couple different things that we know about regular polygons. You may have had different ones there, and that's totally okay. It does not matter that you don't have word for word what I've had. In fact, that would be almost impossible. What's important is you're putting things in your own words, that you're understanding what this means. And this activity here is to help us really cement these different terms and our own understanding of them. As far as some examples, the classic square is a regular polygon, right? It's a polygon, all the sides are equal. Coincidentally, all the angles would also be equal, being the 90 degrees. And that is not one there. I was going to attempt to draw a regular triangle there, but that may be just as... I'll try again. There we go. It's close enough. That would be a regular triangle. And, another example, if you want to push yourself, you could attempt to draw a regular pentagon, and you may have had more success than I just did then. Some non-examples. So in this case, I might just draw a polygon, but clearly not regular. Here I can draw a polygon where all of the sides are the same length, but it's still not regular because the angles are different. Some of the angles are different to some of the other angles. So again, it's close to being a regular polygon, but not quite. All right, on to our next term. All right, so this one is convex polygon. So again, pause the video. I want you to fill out these sections for what you think a convex polygon is. All right, so hopefully you've gone through and filled out these sections yourself using your own words. An example here, I would put, for myself, I might write down it's a polygon whose vertices, right, these are like the corners or the angles, all point outwards. What do we know about it? Well, we know the angle sum because it's a polygon. Anything you know about a polygon would apply here, right? The angle sum will be given by that. These convex polygons, we know all regular polygons are convex. And there's, like I'm saying, lots of other things we could put here because it is a polygon. Maybe I'll put the sum of exterior angles is 360 degrees. Okay, so again, you may have had your own different things, and you could definitely do that. Other things you could have wrote there was, a three-sided convex is a triangle, a four-sided a quadrilateral. You could have put those names down. There's lots of different things you could have put there. Examples. All right, so here we get to draw an example of a convex polygon. I'll just do the one here. It doesn't have to be regular. We just, whoop, that did not work because one of those edges actually happened to be inwards pointing. Here you can see every single vertice is pointing outwards from the center of the shape. That's the crucial element that makes this a convex polygon. A non-example, bang, there. So in this case, see, they all start pointing outwards, which is all fine. Unfortunately, all of them need to point outwards, and you get to this one, and that vertice actually points inwards, meaning this one is not convex. So now that we've covered convex polygons, the other one's going to be pretty simple for you. We're going to fill it out for a non-convex polygon. So pause the video here, fill out the sections. Once you've done that, unpause the video, and we'll have a look through what maybe I would put. Okay, it is a polygon where one or more vertices point inwards. What do we know about it? So, it's a polygon, and along with that comes everything we know about polygons. They have an angle sum of n minus 2 times 180. They have names. Oh, maybe I could put, the equal number of sides, and like any of these other things that we've learnt. Maybe I'll write something a bit different. They are named based on number of sides. So for example, non-convex polygons, just like all other polygons, if it's got 3 sides, well, you actually can't have a non-convex triangle. In a triangle, no matter which triangle you draw, those vertices will... So maybe that actually would be something you could have wrote there. What do we know about it? They can't be triangles. But from quadrilaterals onwards, you're all good for it. So that's something interesting I hadn't really considered myself. But anyway, what I wrote here was names are based on the number of sides. So for example, a 4-sided non-convex would be called a quadrilateral. If it's got 5 sides, it'll be called a pentagon. 6 sides, it'll be called a hexagon. It doesn't matter that it's non-convex, that convention still applies to it. Let's look at some examples. Here I'll draw a couple examples of some convex. Bang. There's one there. Technically, there's a gap there, meaning this is actually not a polygon at all. Here, I'll fill that in. And here's another example of something that is not a polygon. Okay, and non-examples. Here, let me do a quadrilateral. Okay, there's a example of a non-convex quadrilateral. As you can see, we have a vertice there that's pointing in. And let's look at one that has lots of inwards pointing vertices. Here you got a whole stack of different vertices that point in. By a whole stack, I mean 4. All right, so hopefully this helped you in terms of just summarizing some of these different terms that we've been talking about. So we all have, hopefully now, a deeper understanding of what these terms mean. All right, best of luck, and I'll see you guys in the next video. All right, bye.